right. Hello. How's the sound? Or oh yeah, my Slack. Hello. I'm Marte, and let me take you on a little bit of or show you an example. Imagine that you use Azure as your cloud provider. More specifically, you're using the Northern European service or resources they have, which are located in Dublin, Ireland. And then the horrific scenario happens. A tsunami comes, and it floods the entirety of Ireland and takes down all your resources. Would you know how your system would behave to such a crisis? Most likely not, because you don't have to plan for such insane scenarios. But it is a good thought experiment to prepare what to do in a crisis or unexpected behavior. And that is what I want to give you a little bit of tour of today, how to prepare for the unpreparable. And here, for some reason, there's a bit of optical illusion on my rectangle. But not intended, but anyways. So I say that the solution to this preparation is a combination of DevOps and what's called chaos engineering. That's what I'm going to talk about today. First, a little introduction. I'm Marte, the girl on the picture and the girl here. I'm 25 years old. I'm a backend developer and DevOps consultant at Netlight. And I love learning things by teaching it to others, while also pushing my boundaries, which is what brought me here today. Also, some of my recent hobbies. I'm very obsessed-based, so I have one hobby per season. So it's been slalom, chess, volleyball, and Mario Kart recently. And on the left, you can also see my coding companions, the rubber duck, and my mechanical keyboard. So let's start by explaining what DevOps is. Here you have a great Google definition of it. And it's basically a development process that aims to optimize the integration between development or the developers and the people who are responsible for the operations of the system. This is a very common loop to show when talking about DevOps, because the point is to have a continuous integration between the two systems. So on the right, you have the dev section, the developers who do the testing, the building, the coding in opposite order. And then you have the operations side, which does the deployment and the operational and monitor. Anyways, so DevOps tries to automate the step between each of these sections. And there's a lot that can be said about DevOps. And in this talk, I'm just going to focus on a couple of the technologies, namely Docker and Kubernetes. Yeah. So for those of you who are new to the concept of, or to Kubernetes and Docker, it's basically, it all is about containers. We had some great talks earlier about Docker and Docker images, so you might have understood already what images are and what containers are, but it doesn't hurt to repeat it. So you see, the image is a snapshot of your application to ensure that you have like the same application over time across machines and everything. When images are run, they become containers that are hosted on Docker, for example. And then, so this is one way to get your code out public. And then on top of that, you have Kubernetes, which is adds a layer on top where you can configure how these applications work in operation. For example, you have when you can configure that if something goes down, it automatically goes up again. You can have backups, and you can have several configurations of how you want your system to behave. So all in all, sounds very good for our tsunami example I just showed you. And yeah, just the main point you want to take away is that a running application is the same as a running container, which is similar to the term pods, which is what you call what you have in Kubernetes. Now I've talked a little bit about DevOps. So what is chaos engineering? Here's another Google example or result. So the point of chaos engineering is basically to plan experiments that intends to break a system, trying to take it down in often unpredictable ways. And the goal of it, so it's like testing your system, and then you want to see where are your faults and what can you do to prevent them. So in my head, this seems like some sort of attack, a war, similar to some games we have. So, for example, the classical Space Invaders. I hope a lot of you know of this game. Here you have like a similar scenario, and what if I told you that I have a way to stress test a system set up in Kubernetes in a similar pattern as this game? Namely, Kube Invaders. This is an open source repo on GitHub made by Lucky Sideburns that he introduced to Kubernetes official blog in 2020. And it basically has the same concept. You're the spaceship at the bottom, and the top is your applications. It's the pods in the Kubernetes cluster. And this is what I've played along with or around with for this talk. Or some explanation, we will be the ship at the bottom, and the aliens are what we call the pods. For example, the container that runs your application, like vg.no. And what you see as a server figure or something is a cluster. For example, I'm using Minikube, and this is where the pods are running. I will focus today on killing the pods and trying to take them down, because when all pods are dead, the system is down. So, yeah, want to see some live attacks? I'm drawing up the scenario that will happen. Here we have the good guys. Those are the aliens, those are the system. They want to survive. They will try to survive, and I have configured 3 different Kubernetes tactics or defense mechanism, which is a pod setup, deployment and replica setup, and deployment replica with startup time. Then my goal is to try to take them down. This is the time for some live demo. I'm very curious how that will go. I can just take that down. All right. The application to the left is the Kube Invaders game. It's hosted on my computer. This is just locally. And currently, it's... the machine disappeared. What happened now? Let's try to refresh this. This is expected. Yay, it's back. So now we have my spaceship. I'm moving it. and have full autonomy to shoot things down. Currently, the only thing on my screen is the server, and that doesn't really matter for me. But I'm going to set up now the 3 defense scenarios I showed you, starting with a pod. I wanted to show you also the YAML file that describes these different defense mechanisms. And they're quite simple. They're taken from Kubernetes' own documentation, just like the standard setup, how to set up a pod, which is what I'm showing you now. So here we have a pod, some metadata, and most importantly, the container that will be running. So for me to put this up, I just need to create the namespace and then apply this file. kubectl is Kubernetes command line interface. Now it should pop up on the screen. Yay! It has some annoying movement, so I'll just disable that. And now I'm going to just show you what happens now. For some info is that this is it's been a pod is just a running application, and this has not configured any fallback mechanism. So there's no way to reboot it, and there's no replicas. So I assume you know what will happen when I shoot it, but let's try anyway. Beep, beep. Yeah, it's dead. So here I'm all alone. I conquered the universe, and I'm all happy. But that's not really what's happening in IT or for applications in 2023. So let's look at a setup. I just want to go back and show my little cowboy face again. So now they have added automatic restart, which is called deployment in Kubernetes. And they've added 7 backups because they noticed that I attacked them. So let's see how I will handle against them. So here we have a new YAML file that will now has, so this is the exact same specification and container from the last step. But now it's also added replicas, and it's of the kind deployment, which means a restart after the killing. So let's see. I'm just killing the namespace. I think there's more smart ways to do it, but that's the case for me. So I'm just deleting namespace, creating namespace, and applying a new YAML file. Now we should see 7 aliens popping up. Great. So let's see. I think I'm gonna take full screen for this, for the full immersive experience. And I'm gonna try my aller beste, my very best to shoot them all down. Boom, boom. Oh, okay. I think I got a little bit of stage fright because I'm usually better than this. But the pattern is still the same. I know I cannot defeat this with the limitation of my skills and also the game. So I would almost encourage one of you to come up and try, but I won't do that. But now I tried to kill it, and we saw consistently that they popped right back up quicker than I was able to defeat them. So in this case, we tested the system, and it's actually resilient against my attack. But maybe you noticed that, back to my cowboy face, I'm very fond of this. Let's see. Right now, we lived in a fantasy world where restart took 0 seconds. It came back up right away. So now, since I don't like losing, I've added some restart time. So now it takes about 10 seconds for the pods to go back up. And now we've added a third color, yellow, which indicates restart. So I didn't explain earlier, but red is dead, and then yellow is restart, and green is alive. So now, for me to succeed, to take down the system, I should, as long as there are no green aliens on the screen, I'm happy, because there's no active running applications. So let's see the third example. Takes a couple seconds. And my terminal is a little cropped for you. I'm sorry about that, but you get the idea. Creating namespace, and then applying, let's explain the last YAML file. Here we have, very similar to the last YAML file, we have a deployment. And the new part here is I've added sleep, just a superficial command inside the container, and also some timeout seconds. It should mean 2, 3, or 5 seconds together, but with my experimentation, it's actually 10 seconds. So don't ask me about that. Oh, yeah, sorry. Oh, now I created the old setup. So give me a couple seconds more. Right. There they are. Now they're yellow for the startup, of course. I'll just give them a little bit of time to actually prepare for this attack. Okay, they seem to be ready. Let's try. Ooh, ooh. All right. Yay. Thank you so much. So that was much easier and maybe more realistic in real life. We saw now that they came back up again quite quickly, but if I had actually kept shooting or attacking or whatever, I could effectively keep the system down as long as I wanted to, which is a vulnerability. So from here, now I've had I've had my try to test the system, and I would come back and inform the developers of these vulnerabilities. So that's the 3 defenses I prepared for you. And that was fun and all, but what's the point? I might have said it already, but just to reiterate, the goal of such chaos engineering examples is to identify failures before they become outages. So also keep in mind that real attacks are usually way more advanced than what I just showed. But this Space Invaders, Cube Invaders example was to illustrate actually what's happening in an attack like that and how to see how your system behaves. And for the historically interested, chaos engineering as a principle became relevant when IT companies started to pioneer in large-scale distributed systems. Specifically, Netflix in 2010, they introduced a practice called Chaos Monkey, where they take down random apps in production and see how their system behaves, which is quite ballsy for a company like Netflix. But it does improve their system over time, although they are vulnerable at the moment. And just a summary on where it is used. Netflix, as said, and Amazon, Google, Facebook, Microsoft. So mostly international companies, the global big ones. But I did my research that also Schibsted here in Norway is practicing it, which is pretty cool. And that's almost at the end for me, because this is my conclusion. You never know when you will be under attack or have some disastrous thing happen to your servers. So do a little test and try to be the villain of your system and try to shoot them down. It's very fun and it's a great learning experience. So for some credits, big shout out to Lucky Sideburns, who is the inventor of Cube Invaders, and also Amund Tenstad, a colleague of mine that both helped me with the technical part of this talk and the setup. And he even contributed the color difference, the red, yellow, and green, in the Cube Invaders repo. So thanks to him.